Hello, one and all present here. My name is Amit Kumar Singh, and welcome to my class on derivatives. Probably all the theory parts on derivatives till now already I have covered in all my previous sessions. So I believe you have seen all my previous videos. Then only it makes sense for you to watch this video. So in my previous video, I have discussed about Greek letters, and I talked about the meaning of different Greek letters, either the delta or gamma or vega or rho or theta. Already I have discussed about them. Already I have discussed about the different forms of Greek letters. If you're not aware of Greek letters, please make sure that you watch my previous video where I spoke about all the different forms of Greek letters. So this is a theoretical description of all the different forms of Greek letters. At the same time, uh, this is the Excel form. You can, if you would be really interested to know more about Greek letters, you can watch my video also where I have discussed about them in my previous classes, or you can watch my Excel sheet. So this sheet, uh, Google Drive, I'll share all the link of these sheets. So you can watch, not watch, you can solve this, you can see these questions, you can understand how it need to be done. Along with that, if you are really interested for the subject called derivatives, you can see these problems. All these problems I have solved here in MS Excel related to binomial tree model or related to a Black-Scholes model. Already I have solved, but the kind of problem what I have taken a little bit difficult. There can be two-stage or three-stage model, but for Bangalore City exam only the one-stage model comes. Okay, so already theoretical part, everything I've discussed in the previous classes. So if you are weak with the theoretical concept, make sure you watch that video first, then only you come and see this video. Okay, guys. So I hope you are enjoying my sessions. So don't forget to click on the like button if you really like all my previous hard works, what I have done for your exam preparation. So talking about today in this class, the numericals, what we are gonna cover. So we'll cover the remaining numericals, what I have not done till now. Okay. So so suppose see this question number 7. The RK Limited quote at 100 rupees. So RK Limited quote right now is 100 rupees. It means the present stock price is 100 rupees. It means the present stock price is 100 rupees. This is the present stock price, that is 100 rupees. Then the price in the next 6 months may jump to 115 or fall to 90. So time is 6 months. So remain next thing is important is the time is the 6 months. So the price right now is 100, and next 6 months they only ask one stage model. So in 6 months it can become 115 or 90. So it can become either 115 or it can become 90. Okay, so with this you can find the value of u. U would be 115 by 100. So that is 1.15. And then you can find the value of d. D is 90 by 100, that you will get zero point 0.9. Okay, so you got the value of u, you got the value of d. Okay, fine. Then what you need to see after that, what is the value of 6 month call option? Okay, next word they are using call option. So this is important with exercise price of 100 only. This is at the money option contract. So the strike price is also 100 only. So the strike price is also 100. So what you can do, find the FU value. So FU is maxima of ST. FU is maxima of ST minus K comma 0. So your FU would be equal to maxima of 115 minus 100 comma 0. So 115 minus 100 is 15. 15 comma 0. What is the bigger value? 15. So the FU value would be 15. Similarly, the FD will be maxima of 90 minus 100. So the 100 is the strike price comma 0. So the value of FD is maxima of minus 10 comma 0. So the FD value would be equal to 0. So FU is 115 and FD is 0. So you get fu, you got fd. So it's like what we used to do with the decision tree model. Same thing we're going to use it here. So, and I need the value of f naught. So I need the value of f naught. So here I need the value of f naught. So before I need the value of f naught, I need to calculate the value of probability. Probability formula already I have I have formulated. I shown the step by step how to calculate the probability. Otherwise, that direct formula e to the power t minus d divided by u minus d. So r is not given, is it, in this problem? Time is 6 months and r I guess is not given. No, r is given 20%. So r is 20%. R is 20%. So the r is 20%. Time is 6 months by 12 minus d. D is 0.9 divided by 1.15 minus 0.9. So with this I can find the value of probability. So probability, this is 1 by 2. So e to the power 0.1 minus 0.9 divide by 1.15 divide by zero point 0.9. So this is zero point 0.9, this is 0.15, this will be 0.25. So first, what is the value of e to the power 0.1? So e to the power 0.1, so e to the power 0.1, so e to the power 0.1, if you understand e to the power 0.1, e to the power 0.1. So now you need to understand this, that E is equal to 2.71828. This is the value of E. Now I want 2.71828 to the power 0.1. So I want this value to the power 0.1. I want 10th root of this value. So how to do this? So how to do this? So already uh, in my last, not last, uh, before last class, I have discussed how to do this calculation by using normal calculator. I have explained in the steps what are the steps you need to do. So already I have shown this. If you notice in this problem, that value is not given to you, that value is not given to you. So how you can do that? So that part you can use with normal calculator. So in normal calculator, first write, in normal calculator first write 2.71828. Okay, then what you'll do, then press square root 12 times, then press square root 1 2 3 4 5 6 7 8 9 10 11 12, then press square root 12 times. Okay, then this is the second step. Third step, what you do, then do -1. After that, whatever the answer you get, do -1 and then equal to. After, first do -1, then equal to. Okay, then the fourth step, what you do, in the fourth step, do into what is the power? Power is zero point 0.1 into zero point 0.1. So into zero point 0.1 equal to. So into zero point 0.1 equal to. Then the fifth step would be what? Fifth step is +1 and then equal to. Okay, so this is the fifth step. Then in the sixth step, what you do? In the sixth step, what you do? Press equal, into equal to. Do that 12 times. Into equal to do 12 times. Okay. So once you do into equal to 12 times, so after that you'll get the answer. So then you got the answer. So you can try this with your normal calculator, you'll get the answer. Okay, so you will get this as the answer. What answer you get? 1.10517. Okay, so 1.10517. 1.10517 minus zero point 0.9 divide by So this divide by 0.25. Okay, so with this you'll find the value of probability. So 0.82068. So after that you will get the value 0.82068. This is the value of probability you will get. This you have to do step by step. Once you're done with probability value, then this is F naught. F naught is the initial premium. Okay, so don't get confused. What is F naught? What is FU? FU? What is FD? That is the payoff. Normally in binomial tree model, we use the symbol called F naught. So I can write P also, doesn't matter, because I hope you all are a student of mathematics. So what variables I am using doesn't matter. I have 26 alphabets. I can use them in any permutation, combination. All that doesn't matter to me. So this F naught is the initial premium. So initial premium, what the long position holder, one minute. That is the initial premium, what the long position holder would pay to the short position holder at the beginning of the contract. So that is the initial premium. So this is F naught. So F naught is equal to e to the power r. What is the value of r? R is what is r? What is r? R is 20%. R is 20% and time is 6 months. Time is 6 months. P is uh, P you got 0.82068. That is 0.82068 into FU. FU is 15. FU is 15 plus 1 minus P into FD. So FD normally is in turn to be 0. So you can no need to find what is 1 minus P, because any number multiplied with 0 is that value only. So once you get this, this is e to the power minus 0.1 into, so you can multiply this 0.8082068 into 15. So the final answer you get 11.1, 11 point something, 11.1388. So 11, you can say 11 rupees approx. So you'll get approximately 11 rupees. So 11 rupees would be the initial premium that the long position holder will pay to the short position holder at the beginning of the contract. So whenever you talk about option contract, so in the case of option contract, the long position holder have right but no obligation to follow the contract in the future. So in order to enjoy this right but no obligation to follow the contract in the future, so whenever the option contract starts, the long position holder will pay an initial premium to the short position holder. Okay. So already, what is the value of e to the power 0.1? What is the value of e to the power 0.1? That is already, I have explained you how you can determine. So already I explained you how you can determine that value. So already I explained you how you can determine that value. Already explained you how you can determine the value. Now if I'm asking e to the power minus 0.1, that is nothing but 1 divided by e to the power 0.1. So I believe you have seen all my previous video, so you can easily understand. So ultimately, whatever the answer you get, that is the answer. Here the value, whatever the value you get, you can divide 1 divide by 1.010517. So that will give you the answer. So that is nothing but that is 1 divided by this value. So this is 0.90484. So you'll get 0.90484. That is the value of e to the power minus point. Okay, so fine. So in same thing, if I have to do by using Black School's Merton model, so the premium on call option, so that is S n d1 minus k e to the power rt into n d2. Okay, how to find n d1 and d2? So we'll find d1. D1 is log e of s divided by k plus r plus sigma square by 2 into t divided by sigma root t. So you find d1. Once you find d1, you'll find d2. D2 is d1 minus sigma root t. Once you find d1, d2, then I'll find nd1, nd2. So that nd1, nd2 I can find with no cumulative normal distribution table. You can use it from the Google and you can see the value the way we used to find the value of normal table or NT-log table, or in statistics you use chi-square, t-test, all that. Like the same way you find the value, so with that you will get the value what you see from the table, that is the cumulative normal distribution value. That is nothing but that value what you get for d1. The value what you see from the distribution table would be, that is nd1. Similarly, the value what you see for d2, that is nd2, and then you will get the premium on call option, input option. Okay, fine. So I hope you are understanding. A very easy problem. So you can see this problem. Okay. So this is the problem. Maybe after this, any problem which came based on options, risk neutral approach. Once let me see a risk neutral approach if there's any problem. Okay, so now we'll do this problem. Hmm. Same like what we had done. Same problem. I believe you can do it very easily. So the current market price, so the current market price S is 420. The current market price is 420. Within 3 months, it can either become 500 or it can become 400. Okay, and so what is the strike price? R value, R is 8%, and 3 month contract is given, and call option they're asking you, and the strike price is 450. So the strike price is 450. So first thing you have to find is FU. The FU value is maxima of ST. ST means 500 minus 450 comma 0. Okay, so the value of FU you'll get is 50. Okay, now find the value of FD. FD is maxima of 400 minus 450 comma 0. So the value of FD you will get is 0. So you got the FU, you got FD. The next thing what you have to do, the next thing you have to determine is the U value. U is nothing but 500 divided by 420. That is U. What is D? D would be 400 divided by 420. So you will get the value of U and D. You got U, you got D, then you can find U minus D. Okay, so then the next thing I need to determine is probability. So the next thing I have to determine the value of probability. Probability is e to the power RT minus D divided by U minus D. So e to the power RT, that part is already given. That part is already given in the problem. You can see this value. So this value is already given. Okay, so how you got this value? That is e to power r. R is 8% and t is 3 months. So 3 divided by 12 is 1 by 4. Then 8% is 0.08. 0.08 divided by 4 is 0.02. So this is the e to the power rt value. That is 1.0202. So you do this calculation, you'll get p value is equal to 0.2848. So once you get the p value, so now everything you got fu is 50, fd is 0. You understood this? Okay, so that e to the power e value is also given to you, and e value is also given to you. E to the power 0.02 is given to you. That is 1.0202. Now e to the power minus 0.02 would be 1 divided by 1.0202. So that value also you can determine. That value also you can determine. So once you get this, now again I already have done this, but I'm doing it again. So the initial premium is e to the power minus RT p into fu plus 1 minus p into fd. So if not e to the power minus RT, already we got the value 0.9802. P value we got p as 0.2848. 0.2848 into FU. FU is how much? FU is 50. FU is 50. So you can find the value of F naught. So this is the value of F naught. So approximately you will get this answer as 14 rupees as the initial premium. Okay, so 13.93 something I'm getting. So approximately you can say the initial premium is 14 rupees. Very simple. So guys, I hope you are enjoying this calculations and all. They're not at all difficult to work on. So I'm starting from the end. Nothing is left already. What everything I've done till now. Already I've done this seventh question. Okay, let's see if there's no other problem, then we'll do sixth one. I think other of risk neutral, you can do it by yourself, there's nothing big thing. Let's do this question number 6. So you can see this problem. The share price of XY Limited is selling for 104 rupees. ABC buy one 3-month call option at a premium of 5 rupees. Exercise price is 105. Let me write S is 104. Okay, so AB Limited, ABC buys 3-month call option. He buys 3-month call option. Okay, where the strike price, where the exercise price is 105. Okay, so call option. So S is less than K. So S is less than K. So this is out of money call option. So S is less than K. If S would be greater than K, then this would be in the money. So here 104 is less than 105. So what is the ABC payoff if the what is the premium? They have given the premium. So the premium is 5 rupees. Okay. So premium is 5 rupees. So 105 is the strike price. Okay. So he took call option and he paid the premium of 5 rupees. The share price of XY Limited is 104. ABC buys 3-month call option at premium of 5 rupees. The exercise price is 105. What is ABC payoff if the share price is 100? So if the share price become 100, so if the share price become 100, then ABC will not exercise the contract. Okay, ABC will always exercise the contract only when if the future stock price become more than 105. If the future stock price become less than 105, then the investor will never exercise this contract, or then he or she will lose their 5 rupees. Then 105. So 105 means 105 means he'll exercise, even then 105 minus 105 minus 5, even then he'll lose 5 rupees. 1010 he'll get 5 rupees. 115 he will get how much? He'll get 115. So 115 minus 1. So he'll get 5 rupees. 120 10 rupees. That is what we do. Okay, so what is the PO of seller call option? So all that I can do. So very easy problem. So very easy problem. So S value they are asking us take 100, 105, 1, 100, 5, 10, 15, 20. So 100, 100, 5, 10, 15 and 20. Okay, and your strike price is 105. And your strike price is 105. It took you strike price of 105. So the strike price is 105. S and K, then SK. Okay, so you got the value of S, you got the value of K. Okay, so what I can do, you can see what is type of options. If I want to see S is less than K, this is out of money, this is at the money, this is in the money, this is in the money, this is in the money. So I can talk about these option contracts. So I can talk about the payoff of long call. So if I talk about long call, so the long call that would be same formula to use, the maxima of P minus K comma 0 minus P. So the premium, premium is how much? Premium is how much? Premium is 5 rupees. Premium is 5 rupees, you know that. So every time I'll do this calculation. So So here for first one, so I'll write maxima of 100 comma 105 comma 0 minus 5 rupees. 5 rupees is the premium, minus 5 rupees. So minus 5 rupees. So if the final spot price, like if it expiring out of money, the investor will never exercise the contract and he will lose the five. Here he'll lose the initial premium. So the investor P of, if I talk about the investor P of long call, P of, the profit of long call is the loss of short call. So the short call P off. So till that time long call will not exercise, short call would be enjoying with the premium. So here he so if you talk about long call, so this is 0, this is minus 5, this is minus 5, so this would be minus 5. Whatever is the loss of long position holder, that is a profit of short position holder. If you see 105, 105 also, 105 minus 105 is 0, 0 comma 0, which is bigger number 0. Then 0 minus the premium. The premium was 5 rupees. Premium was 5 rupees, so you lost the 5 rupees. So other person would be still enjoying with the premium. 110 means 110 means 5. And so you get 110 minus 1055. 5. So 5 and 0, which is bigger number? 5. Okay, so the premium is again 5. So here you get a premium of 0. P of 0. This is P of 0, then this P of is also 0. Then 115. 115. This is what? This is 10. 10 minus premium. Premium is 5. This is the profit of 5 and this will be the profit of 10. Here this is profit. If this is 10, 5, his loss will be 5 and 10. So 115 minus 105, that is 10. 10 minus the premium. So 120 minus 10, 15, 15, 120 minus 105, 15. 15 comma 0, which is bigger number? 15. 15 minus the premium means 5. This is the payoff of long. This is the payoff of long call holder. Similarly, this is the payoff of short call holder. So the profit of long position holder is the loss to the short position. So whenever the long position holder is not exercising, then automatically the money what the short position holder get at the beginning of the contract, that would be the incentive for the short position holder. So they're asking you to draw the payoff diagram. So you can draw the payoff diagram for long and short position holder. So you can draw the payoff diagram for both long and short position holder. So you can write 100, 105, then 110, 115, then 120. So 100 means long call I'm talking about, minus 5. Then 105 minus 5. Then 110, 0. Okay, no profit, no loss. 115, 5. Then 120, 10. This is the payoff diagram of long call. Similarly, you can do the payoff diagram of short call. So this is 5, this is 5, then this is 0, then this is negative, then this is negative. This is the payoff diagram of short call. Now you can see this next problem. You can see the next problem. So now you can see Mr. MN purchased 3 month call option. Mr. MN purchased 3 month call option for 100 share of PQR Limited while at the premium of 40 rupees per share with an exercise price of 560 rupees. He also purchased 3 month put option. He also purchased 3 month put option for 100 shares for same company at premium of 10 rupees per share with exercise price of 460 rupees. And the market value of the share on the date of Mr. M purchase of, is 500. Compute the profit or loss that Mr. M and would make, assuming that the market price at the end of 3 months can be 360, like 660 or 500. Same problem. Everyone, please try to solve this problem. How will you solve this? So you can see the market price of stock is 500 rupees and you bought the call option for 560 rupees. So K is more than S. So this is out of money call option. This is out of money call option. And you can see the K, the strike price for put option is 460 and S is more than K. So here this is out of money put option. So this is basically you took log call and log put together at different strike price. So ultimately you are creating a long strangle. The strategy is called long strangle. So you have to find his profit and loss at the end of 3 months if the price remain like this. So already I think I have done this problem in past also in a previous video. Doesn't matter, I'll do it again. So you know the payoff diagram of log call. Payoff diagram of a log call. You know the payoff diagram of log call, that is maxima of ST minus K comma 0 minus P, and payoff diagram of a log put. So that is maxima of K minus ST comma 0 minus P. So if I draw the payoff diagram for this, if I draw the payoff diagram for this, so the present spot price is 500. You choose a strike price of 560. There you took the log call and you paid a premium of 40 rupees. Okay. Then at 460 you took log put. At 460 you took log put and you paid a premium of 10 rupees. Okay. This is the way. If the stock price trade between 460 to 560, the trader will get a loss. While if it trade anything below 460 or anything above 560, the trader will book a profit. So ultimate payoff diagram for the log strangle is like this. This is the payoff diagram of a log strangle. So why this dip is coming? Because if the stock trade between 460 to 560. Normally we take long strangle whenever we are expecting volatility in the market. So you'll use the formula maxima of 360 minus 560 comma 0 minus 40. So you'll get minus 40. Here you will get maxima of 60 minus 560 comma 0 minus 40. So here you'll get 60. This is maxima of 500 minus 560 for 0 minus 40, you will get minus 40. You understood this, very simple. So, so if I calculate the net payoff, one share option contract. So this is minus 40 plus 90. This is plus 50. This is 60 minus 10. This is plus 50. And this is minus 40 minus 10. This is minus 50. Okay. So this is on one share. So if I do the net payoff on 100 share, so into 100 you do 50 into 100, 5,000 rupees, 5,000 rupees, and here loss of 5,000 rupees. This is what you need to do for this problem. Okay, so you need to understand this part. You need to understand this part when you see this. So you took a log call at 560. So if you took log call at 560, so at 360 you not exercise, you lose you 40 rupees. At 660 you'll exercise, so you will get 100 rupees, but you paid already 40 rupees premium, so your net profit would be 60 rupees. At 500 you will not exercise, you lose 40 rupees. Okay, now similarly for the put option, you took a log put at 460. So if it become 360, so you'll get a profit of 100, but you already paid 10 rupees. So you got a profit of 90 rupees from the log put here. At 660, you not exercise, you lose 10 rupees. At 500, you will not exercise because your strike price is 460, you lose another 10 rupees. So this is the profit and loss on one share. So ultimately you can find profit and loss on one share. So minus 40 plus 90. So this is plus 50. This is plus 50 and this is minus 50. Similarly, you can do for 100 share. So Mr. Ahmed purchased 3-month call option for 100 share at a premium of 40 rupees exercise or 560. He also purchased 3-month put option of 100 share at a premium of 10 rupees per share at exercise price of 460. The market price on the date is 500. Okay, that's it. So this is what you need to do. I hope you understood this. Very easy. So this is what you need to do for this problem. Very easy problem. So this I hope you understand. Like in risk management and all, the level of problems are not at all difficult. The problems are very easy. You can do them very easily. Basic concept, if you understand, you for solving won't be difficult. The concepts like Black-Scholes model, binomial tree model, they are somewhat little bit difficult problem. difficult to work on, but as per the risk management and derivative subject, they ask only basic question on binomial tree model. That too, it is one step binomial tree model. So again, it becomes very easy at black schools, so they are not asking only. Even then, if you want to know more about black schools model, so you can watch my videos, which is there in playlist about black schools and difficult problems on binomial tree model. So gradually you understand. So if I see the problems, so I have covered all the problem. If I see here, all the problem I have covered, all the theory and numericals, everything I have covered. What is required for your exam preparation. Okay, so question like this, if you see question like this, here they're asking you the expected return. So expected return already I've done in my first class. Already I've done this. If I ask you about the expected return, so what is the expected return? Already I've done. So you multiply the probability with the cash flow that and do the sum of that. That is your expected return. Then for the expected return, a question like this, if I'm asking you, already I've done this in my first class, but even then I'm just for your basic understanding. So you can find this the expected return value, expected cash flow. Here return I'm using, you can use the word called cash flow. So the expected cash flow, that is nothing but that is the sum of their probability with the individual cash flow. Do the sum of this. So this is this is 9 into 0.1, this is 0.9, 13 into 0.25, that is 1 by 4. So 13 is 3, 10. 13 divided by 4. 13 divided by 4 is what? 3, 10, 3.25. This is 3.25. Then this 17 into this is 5.1. 21. This is what? 5.110. 5.25. 25. This is 2.5. So if you do the sum of this, 9, 9, 11, 12, 12 plus 7, 19, 21 carry. So 5, 10, 13, 13, 15, 16. So the expected cash flow for this is 16. So once you get the expected cash flow, then what you can do to find the standard deviation, you can use the formula for standard deviation, summation of PI into your cash flow minus your expected cash flow. So this whole square and take the square root of that. You will get the standard deviation. Then coefficient of variation formula is standard deviation divided by the expected value into 100. So which one is more risky? Which has less coefficient of variation? So less coefficient of variation means more risky. Already in my first class I explained all this. Okay, so once you get the expected cash flow, you can find the cash flow minus expected cash flow. Okay, this you can do very easily. So cash flow minus, so 9 minus 16. 9 minus 16 means minus 7. 13 minus 16 minus 3. 17 minus 16 1. 21 minus 16 5. 25 minus 16 9. So you get cash flow minus expected cash flow. Do the square of this. So cash flow minus expected cash flow. Do the square of this. So this is 49. This is 9. This is 1. This is 25. This is 81. And then multiply this with probability. So probability into cash flow minus expected cash flow whole square. So 49 into 0.1. So this is 4.9. So 9 into 0.25. 9 into 0.25 means 2.25. So then 1. 1 into zero point 0.3. 1 into zero point 0.3. So 1 into zero point 0.3 means what? 0.3. then 25 into 0.25 means 625, 25 square, then 2 decimal, 6.25, and then 81 into zero point 0.1, this is 8.1. So if you do the sum of this you'll get the variance. If you do the sum of this, you'll get the variance. So this is 11, 9 plus 3, 12, 12 plus 3, 15, 17, 18, 1 carry. Then 14, 14 plus 6, 20, 21. So you get variance as 21.8. So the standard deviation would be square root of 21.8. So you found the standard deviation square root of 21.8, and you got the mean. Mean is what? 16. So the coefficient of variance of this would be standard deviation is square root of how much you got? Standard square root of 21.8. So 21.8 divided by mean is 16 into 100. So this I did for one. Like this you can do for other also. Solving would be very easy. Solving like this kind of problem will be easy. So calculate the variance. Square root of variance is standard deviation. Coefficient of variance is nothing but standard deviation by expected value into 100. Okay, so this is what you need to do. Already I have done this in my first class. If you watch my first video on risk analysis on capital budgeting, so in that I have explained all this formula, all that. Just a kind of revision for you. Mm. So you can do that part. You can do it very easily. Hope you understand this. So I have done for this. I have done for project S. Similarly, you can do for project K also. So project K expected return would be 11 into zero point 0.1 plus 13 into zero point 0.2 plus 15 into zero point 0.4 plus 17 into zero point 0.2 plus 19 into zero point 0.1. The sum of this is expected return. So that the once you get that expected value, so subtract the cash flow from the expected value, do the square of that, multiply with probability, take the sum of that. So that you get the variance. Do the square root of that, you get standard deviation. Standard deviation divided by expected value into 100, you get the coefficient of variance. So find the coefficient of variance of both of them, whichever have the lesser coefficient of variance, that is more risky. Okay. So yeah, so you can try solving this. It's not at all a difficult problem to work on. Fine. So I believe I have covered all the problem related to your risk management exam preparation. So then guys, it's time to say goodbye to all of you. So our journey till now is being very memorable, and we spent quite a lot of time with each other to understand the game of mathematics through learning the subject called risk management and derivatives. I believe you understood what risk management is all about, what derivative is all about. So then, guys, it's time to say goodbye to all of you. If you have understood everything, then I believe now you're prepared for your exam. And so I have to say best of luck for your exam preparation. Do well for your exam preparation. So it was really nice teaching you all. So God bless you. Thank you, everyone. Take care. Best of luck for your exam. So thank you, everyone. See you again on some other subject in some other journey. Take care. God bless you. Bye.